Okay, so good morning, everyone. So today we are going to do the lab for week 2. So, I mean, if you go to Moodle, you will see that this is the set of problems. Okay. So please have your MATLAB ready with you. So now we can try the commands listed in the question. So, so now number 1. Okay. So maybe let me share my MATLAB. Yeah. Okay, so you can see that if I take one, I mean, if I take question number 1, I take epsilon, right? So remember, epsilon is just a gap between 1 and the next machine number. So what is the same as 1 over 2 to the 52? Okay. So remember, because we have 52 bits in the significand, yeah. So because a 64 bits floating point system was used in MATLAB. And then, so if you take 1 plus epsilon, then by definition, it should be bigger than 1. Okay, so logical is 1. And then epsilon over 2, 1 plus epsilon over 2 got rounded to 1. So that's why if you type in 1 plus epsilon over 2 bigger than 1, then you get what? Get false. Okay, so that's, we see it again and again already. So now the next one is, now suppose I put h is 1e minus 14, which means that 10 to the minus 14, yeah. Then if I take 100 plus h minus 100, then what should I get? So 100 plus h minus 100, what should I get? Anyone, have you tried this command? Where's my chat box? So you got 1.4 something, and you see, so you don't get back h. So why is that? So h is 10 to the minus 14, yeah. But when you take 100 plus h minus 100, you got something different from h. So why is that? You got slightly bigger than h now, right? Because you see 100 should cancel with 100, and then you should get h, which is 10 to the minus 14. And now what you got from MATLAB is something bigger. So why? Anyone came to the lectures yesterday? I mean, attending the lectures yesterday afternoon. So why is that? I mean, why you don't get h? Rounding. Yeah, but rounding, I mean, why so big? I mean, so the remember, if you remember the lectures yesterday, when you take two floating point numbers very close to each other and you minus, then you get a catastrophic cancellation. Okay, so the errors, the rounding errors for minus two numbers that close to each other is very big, especially when the two numbers are close to each other. Okay, so that's why you don't expect to get h here. Yeah. And now if I have h is 10 to the minus 15, you see, now you get, I mean, the errors now is, I mean, Now you just got 0. Yeah. So why is that? You don't get h anymore. So why is that? Yes, 100 plus h get routed to 100. But because, why is that? Because remember, you know, the gap between 100 and the next machine number is epsilon 100. Okay. And epsilon 100 is this number 1.4 10 to the minus 14. So h is less than this gap. Okay, so if you remember, h is less than this gap, so that's why h, you know, like 100 plus h, it just got routed to 100. So remember, you know, like if I show you the somebody want to get in. So remember I plot the suppose I want to share the whiteboard. Yeah. So you see my whiteboard. Okay, so now let me erase. How do I erase it? So maybe I don't need to erase this. Should be erase button. Well, maybe I don't need to erase it. Yeah, so let me or here erase it here, clear on the drawing. Okay, so now you see my whiteboard, right? So now you see this is like 100. Okay, and the next machine number is 100 plus epsilon 100. Okay, so this is the next machine number. And epsilon 100, you see that it will be about 1.4 10 to the minus 14, right? So the h is smaller. So 100h. So somebody want to get in, sorry. So 100h is 100h is right here, somewhere in the middle here. Okay, so it just got routed back to 100. Yeah, so that's why we got, because h is 10 to the minus 15, right? So that's why 100 plus h got routed to 100. So then you got 100 plus h minus 100. It just, you know, equals 0. Yeah. So now go back to MATLAB. Okay, so now you have yeah, so we saw it already. Yeah, we saw epsilon 100 is this number. So remember, epsilon without parameters, it's just epsilon of 1. Okay, and 10. So how do I get epsilon of 100? So epsilon of 100 is you have to express 100 as a binary number first. Yeah. So what is the binary number of 100? So decimal to bin of 100. So is this number. Yeah. So now suppose I try to show you how to get epsilon of 100 by just calculation. Okay, then so now I want to take 100. okay, and I convert into a binary form, so it will be 11000100, right, in binary. But what is the floating point of this one? So it will be 1 dot, then 100, and then 1, well, not 100, but you know what I mean, yeah. So 100 100 multiplied by 2 to the, and because now how many dot you move? So 1 2 3 4 5 6, so 2 to the 6, yeah. So then, so what is 100 plus epsilon of 100? Well, it will be, you know, you turn on the very last digit, so 1 dot 1 1 1 and 1 0 0, yeah. No, sorry, the last one will be 1, yeah. So last one should be so I should erase this one. So the last one should be 1, okay. And again, this is binary, yeah. So then epsilon of 100 will be, you know, 1 over, so 1 2 3 4 5 6, so 2 to the 6 multiplied by no, I'm sorry, we we forgot that we have 52 digits, so that is not the correct. I think I have to erase this. Yeah, it's just not. Actually, we have to we have to put up to 52 digits. So because we are in a floating point system, yeah. So actually, you have to put more dot, okay. Yeah, and the 1 here should be in the 52 digits, yeah. So 52. Okay, oh sorry, 52nd, yeah, 52nd digit. Okay, multiplied by 2 to the 6. So then, you know, epsilon 100 now will be just 1 over 2 to the 52 times 2 to the 6. Okay, and now what is this number? So this one will be 2 to the minus 46, yeah. So now if you put into MATLAB, you will see that 2 to the minus 46 2 to the minus 46. So if you put in MATLAB, you will see that it exactly equal epsilon of 100. Okay, so we will talk about this calculation in the tutorial, but now I just show you the quick calculation of epsilon of 100. And then when you put in MATLAB, you see that epsilon of 100 is the same as 2 to the minus 46. Okay. So any question about this? So then you see that 100 now plus epsilon of 100 will be bigger than 100. Okay, because 100 plus epsilon 100 is the next machine number after 100. And then if you take epsilon of epsilon of 100 divided by 2, then you got 0. So it's like before, you know, so now it got rounded back to 100. Okay, so now that is question number 1. How about question number 2? So question number 2 is how you plot a surface. Okay, so now so the sphere is a special surface that MATLAB has a special command for you to plot it. So you just type in x, y, z equals sphere. Okay, And then if I just take the serve command, yeah, X, Y, Z. Now you cannot see my output. Maybe let me share the whole screen, yeah. Share the whole screen. So as you see my pictures, my figure. Okay, so you can see the figures of the sphere, yeah. Okay, so now, okay, if you want to get rid of the grid, you know, you can say that shading interpolate, something like this. Then you get a nicer pictures, okay. But now actually, if you want to hide away, a point on the sphere, okay. So suppose I take say 16 and 3, yeah, 16, 3. Then you put it not a number, and now you plot it again. You plot it again. So serve X, Y, and Z. You plot it again. So you will see that. You see now the sphere got a hole in it. Yeah. Because so what it does. So remember when you say 16, 3, yeah. So it means that X now, so if you check the size of the matrix X is a 21 by 21 matrix, okay? And when you put X is 16, 3, it means that you take the 16th column, 16 row and the third column, and you set it not a number, and it corresponding to this point, okay? And you set it equal not a number, and it's become not visible on the surface anymore, okay? So now let's say suppose I want to use this trick to draw the sphere, but then I want to cut away the part that X is negative. Sorry, X is negative, yeah, less than 0, and Y is negative, and Z is positive. So it means that, you know, first you have to cut the one below the equator, right? And then you have to cut like 1/2 of that, and then you take only the Z positive. So how do you do that? And the hint is you use the find commands, okay? So first you have to look it up. What does it mean? How do you use the find command? Yeah, so help find, yeah. Okay, so essentially it will give you the index of a matrix that satisfies some conditions. So suppose I have like so not a matrix, just a vector first, yeah. So 1, 2, 3, okay, and I want only element of the matrix that is say bigger than 2, okay. Then it gives me the answer is 3. So you see only the third element is bigger than 2. Yeah. So suppose I put say bigger than 0. And then I got all the elements. Okay. So it gives the index. Yeah, it gives the index of the matrix that satisfies the condition. So now how do we use that in this problem? So let me make a new script. Okay, so it's easy to follow. So maybe, so let me first I will say X, Y, and Z is the sphere, yeah. So this one will, if you look it up, this one will parameterize the sphere into the theta and phi polar coordinates. Okay, and then the X, Y, and Z adjust the grid that corresponding to the theta and phi. Yeah. And you know, you use the angles. So now suppose you take edit sphere, and then you will see how the commands works. Yeah. So you see, that I just take theta, okay, from minus pi over 2 to plus pi over 2, and phi is from theta is from minus pi to plus pi, yeah, and phi is from minus pi over 2 to plus pi over 2, and then it used the formula from polar coordinates, yeah, to not polar but from spherical coordinates, yeah, to compute x, y, and z. See, cosine phi, cosine theta, and cosine phi, sine theta, and then output the grid x, y, and z. Okay, so that is how the sphere command works. So now just assume that you have the x and y and the z for the sphere command. Yeah, and now I want to find the index that x less than 0. Okay, so I don't want to use, I don't want to do the whole question now. I just say, suppose I want the x less than 0, right? So I say that the index IDX is the index of x less than 0. So again, so now, you know, IDX is just the index of all the entries that x less than 0, right? And then you set that index to be not a number. Okay. And then you plot it. Now you plot the sphere. Wow, so we use the surf command, yeah? So x, y, and z. So now if I run it, well, I have to give the name. So this one is week 2, 2022. Question? Any question? Any question? Just please type in the chat box. Yeah. So now if you run it, yeah. So if I run it, so what do I see? Where is the figures? So I run it, then now what happened to the figures? So the figures should be, okay, the figures should be here, yeah. So you see the figures, yeah. So you see the x less than 0 has been cut away. No. I mean, if you put a semicolon after surf, it still show the figures. You have to find out the correct. You click on this, you know, you see there is 2 windows. One is the command windows and one is the figures, yeah. Okay, but now this is not the whole story, right? Because the question say that they want to hide away the part that x less than 0, y less than 0, and z greater than 0, you know, so hide away more. So how do you do that? So how do you modify my script to hide away more? So what is the command? So what should I modify this script? What line, you know, to make it hide away more, you know, so it hide away x less than 0, y less than 0, and make the appropriate change to y and z. So how? Yes, but then it means that, you know, IDX2 is only the part z less than, sorry, So it means that IDX2 is just a part that y less than 0. No, I want the, the union of all the condition, not the union, sorry, the intersection, right? I want the intersection of all the commands. So I want all the conditions satisfied at the same time, yeah? So, okay, so maybe let's suppose I try another IDX2 is when y less than 0, right? Then I set y IDX2 equal not a number. Okay. Now see what happened. Yeah. So if I run it. So now, does it look correct? So you hide away you cut away the negative x, okay, and you cut away the negative y, right? Yeah. So now you have only the positive y and positive x, yeah. So you see x from 0, 0 here, and it go to 1, and x from 0, 0 here, sorry, y from 0, 0 here go to 1, yeah. Okay, but z is still from -1 to 1, okay. So now we have to cut away the z is positive, right? So we have to cut away the z is positive as well. So now if I put IDX3 is the part that z is positive, then I set IDX3 equal not a number, okay? Then I plot the surface. Okay, so now if I plot the surface, oh, sorry, unrecognized. Okay, so I have to make this one IDX3. So now if I run it, okay, so this one look like this. So now, you cut away the x is negative, y is negative, and z positive. So now you have z only from 0 to -1. Okay. So that is how you hide away the part of the sphere that doesn't satisfy your condition. Okay, so now the next part. Good question. Yeah, good question. So is there to do the intersection in one line? Yes, I think you can do that. But I think should not be the. Okay, so now let me try to do another way. Yeah. So now suppose I hide away this part. Yeah. So now suppose I do another way. So maybe we make a new one. We cut and paste. So now I don't want to destroy the previous one, yeah. So now I think we can do the other way by saying that, okay, what happened if I put in all the condition at once? So if y less than 0, so this one stands for or, okay? So or Let's see whether it works or not. I have to check. So if you say that like 1 or 1 is 1, yeah, or maybe a single vertical bar. Single vertical bar is okay. So it doesn't have to be double. Okay, or Z positive. Okay, and then you put in X IDX, not a number, Y IDX, not a number, Z IDX, not a number. So see whether it works, yeah? So run it. Okay, I have to give a name. Week 2, version 1. Yeah, still okay. So there is still the same, yeah? I think they are the same. I think you can use double vertical or single vertical. I think they are the same. Because I check it here, see, so 1 or 1 or 1 or 1, I think it's still the same, yeah? So double vertical or single vertical is the same. So help vertical, yeah? It's OR, logical OR, okay? And I think the double vertical can perform the OR between the scalar values as well, okay? So we don't have to do this. I think this is a bit like, you don't need that, yeah? So any question about this one? Everything is okay, yeah? Okay, so the next one is solve the quadratic equation. So now you have to write a function. So now how do you write a function to solve the quadratic equation? So quasolve. Yeah, so you have to write a function called quasolve. So now we have to make a new function. So new and new function. Okay. And now you label this as a quasolve. Well, so maybe you have to type in here. So quasolve. Quasolve. And so now what is your input and what is your output? So what is the input and what is the output in this case? Input ABC, output X1, X2. Yes, it's correct. Yeah. So output, input is ABC, the coefficient of the quadratic, and output is X1, X2. Yeah. So now you can say that, okay, so this function solve, okay, so solve the quadratic equation ax squared plus bx plus c equals 0. Return to roots, yeah, x1 and x2. So you give some description how your function will work, yeah. And when you save it, it recommends you to save as a quasolve.m. Okay, so I don't have anything similar, so I just save quasolve.m. Okay. And now how do you compute x1 and x2? So you just take the formula, right? So put in the formula. So x1 will be minus b plus b square. You know, strictly speaking, you know, we have to check whether the discriminant is negative or equal 0, right? But, you know, MATLAB can handle complex number. So if you have a negative discriminant, I think it still give you the complex roots of the equation. Okay, so but I guess you can check if you're careful. You have to check, yeah. Maybe you have to check whether a equals 0 or not, because if a equals 0, then the division can cause the divided by 0 errors. But suppose I assume that everything is fine, everything is a perfect condition, then I can return x1 like this, and x2 is, you know, I mean, minus b minus the discriminant over 2a. Okay, and I save it. Okay, now I have to write another script called quad test that use quad solve to solve the sum equation. Yeah. And now how do I do that? I make a new script. Okay, so I make a new script. So new script. Okay, so new script, yeah. So solve. So now how do I call the quad solve? So to solve the first equation. So now say part A. Okay, so I have to solve x squared plus 3x plus 2 equals 0. So how do I solve? How do I call quad solve? Yeah, and then I have to write. I have to write the output as well. So ABC and XY is quad solve 1, 3, 2. Yes, correct. Yes. So we can say that. Okay. So x1, x2, okay, equal quad solve of 1, 3, 2. Okay. But now I want to output. I want to output a table. So the table should be ABC. I mean, if you look at the question, yeah. So you have to output the table ABC, then fx1, fx2. Yeah. So maybe let me remind you how to do that. So there's a fprintf command, yeah. So fprintf. So I mean, you can print into a file, or you can print to the screen. So now suppose I want to print to the screen, yeah. So print the results to the screen, yeah. Then now fprintf, and then you print out ABC. So ABC now, okay, so maybe it's better to have ABC, yeah. So A is 1, B is 3, and C is 2. Okay, so now we have to print out ABC. So print out ABC. So as a 3 scientific number. So scientific number %E, and %E. Okay. And then you have to print out fx1 and fx2 as well. Okay, so now we have to define what is f. So f is the function, anonymous function, divided by x square, okay, plus, maybe just take care of the general form. So ax squared plus bx plus c. Okay, so then now you have fx1, so another scientific number, and fx2. Okay, so now you have to give the variable. So x, so you have to give a, b, c, and f of x1 and f of x2. Okay, so then this one will print out. So maybe I make a new line. Yeah, so I make a new line here. Okay, so now if I run it, well, I have to save it first. I'll run it and then it asks me to save it. So save as quad test, yeah, quad test .m. So there's some errors here. So the errors is, so where's the errors? Output x2 is not assigned. Okay, so you go back to, so we set up x1 and this one should be x2, yeah. Okay, so now you save it. You go back to this. And so this one you can say quad solve ABC. Okay, and now you run it. You see, so now the output will be something like A here, B here, and C here. And this is fx1 0 and fx2 is 0, right? But now actually, you know, I mean, if you look into the table in the question, it has only 3 digits after the dot. Okay, so you can have 3 digits after the dot by, say, 1 digit before the dot and 3 digits before. So let's see whether it works. Yeah. So now if I run it, you see, so it says, so 1.3 here. It just means that, you know, 1 digits before the dot and 3 digits after the dot. So you see that the format. So this is a format here. So 1 digit before the dot and 3 digits after the dot. Okay. And you can do the same thing for the other. So 1.3, 1.3. So this one, they call it a format string. You know, you have to give a format. What do you want f command to print? So see, now I'll print out only 3 digits after the dots. Yeah. Okay. So now how do I solve another one? So I solve another one. So I solve part B. Well, you just copy the same thing. You change A, B, and C. Yeah. So now if I cut and paste the whole thing here. Okay. I make a part B, then ABC will change. Yeah. So ABC now will be, so if you look into the problems set, you will see that A is 0.01 and B is 2000. And then C is just minus 0.001. Okay. And you can run it. So you run it again. Okay, then you get the second row of the table. And now you can see that now the fx1 is not 0, but now it will be something like 10 to the minus 8. Okay, and this one is 4.6, 10 to the minus 8. Okay, so it's not 0 anymore. Okay, so now we do the next one. So the part C, we go back to question B later. Okay, but now C is, now I'm going to solve. So this one is not this equation, but you can see the equation in the problems. Yeah. Okay, so now the next one will be A is 1. A here is 1 and B is 2. And C is 4. Okay, now you run it. So you see that now, you know, if you look at 3 cases, yeah. So the first one is very good. You got 0, 0, fx1, fx2 is just 0, 0. But now the second one, okay, you got 10 to the minus 8. And then about 4 times 10 to the minus 8. And the last one is, well, about 2 epsilon, so it's still okay, right? So epsilon is 2.2, 10 to the minus 16. So this one is still very close to 0, so it's still okay. So what we see is only in the second case. So why is that? Why is the error so big? Why f is not equal to 0? So why is that? Well, so now it's time to look at the formula again. Okay, so look at this formula. Okay, so do you see catastrophic cancellation in those two formulas? So remember when we have catastrophic cancellation. So remember the lectures yesterday? You're still there? When to get coffee already? Square root round to be, yes, you see, in this case, you know, I mean, because B and, you know, square root of B squared minus 4AC are close to each other, right? So you got catastrophic cancellation. Okay, so now we have to fix it. So now how do we fix it? So now if you okay, so now we have to look at the formula again. Okay, so now what you have, I have to share the whiteboard. Okay, so now the whiteboard is here. So now let me, so you see my whiteboard, yeah? So clear on the drawing. Okay, so now if you look at the formula, x1 is minus b plus b squared minus 4ac divided by 2a. Okay, so when 4ac is very small, yeah, in our case, that is the case. Yeah, you got, if you look back your, I mean, if you look back the question, in this case, a A and C are very small, you know. So then, so when A and C small, yeah, then B square minus 4AC are very close to B, right? Well, in this case, you know, B is positive, yeah, B positive. Then you can have catastrophic cancellation. Catastrophic cancellation. So how do we fix this? How do we fix the problem? So how do we fix the problem? So rewrite the formula. Yes. Okay. So we have to rewrite the formula. So now, if you rewrite the formula, you multiply and divide it by the same thing. You know, I mean, b plus square root, b plus square root. Yeah. And then, you know, I mean, if you remember the formula, then this one will be b square minus 4ac, right? Remember, inside the square root, it just be minus 4ac, yeah? b square minus 4ac, yeah? And you have the identity x plus y, x minus y is x square minus y square, okay? So I use that identity. So now it will become b square minus 4ac minus b square over 2ab plus b square minus 4ac. Okay, and this one give you, you know, minus, I mean the b square got cancelled here, and then 4a got cancelled with 2a, so you got minus 2c, okay, over b plus b square minus 4ac. Okay, so that is the alternate formula. So only when b positive. Okay, so b positive, then you could have a catastrophic cancellation. So I think it's correct, yeah. So now you can go back to the the problems. You can go back to quad solve, yeah, and then you rewrite the script. Okay, you can rewrite the script to. So let me stop this and I go back to the MATLAB. Okay, so now you can rewrite the quad solve to handle that case. Okay, so now this one is only, so the catastrophic cancellation can happen when you have B positive, right? So this one could have catastrophic cancellation when B positive. Okay, so you say that, okay, so now if B positive, then maybe we use a different formula. Okay, so we say that, okay, so if B is positive, you define x1 to be something. Okay, so else you use this formula. Okay, and I think you can do the same for x2 as well. So I just leave x2 here. But now, what is the another formula? So the other formula is, now I forgot what is, I didn't write down. So let me go back to the, Let me go back to the whiteboard. So the whiteboard is here, yeah. So it will be minus 2c, okay, over b plus square root. Okay, so minus 2c. So let me copy it down, right? So minus 2c divided by b plus square root of b squared minus 4ac. Okay, so you can now let me go back to the MATLAB. Question? Any question? So now you can see that, okay, now I have modified if be positive, then I have this alternate definition for x1, yeah. But you can have, okay, save it. So remember this case, when b in negative, you can have a catastrophic cancellation. You can have another formula here as well. I just leave it here for the moment, but because we run out of time. But now if I go back to this, okay, I run it. So you will see that now the second case got improved. The second case got improved, right? So you see that before it like 10 to the minus 8, and now it's 0, right? With a new formula. You see the catastrophic cancellation caused the problem, right? But now think about the second roots, why we cannot fix it. Okay, because we don't have time now. So think about it. Why we cannot fix the second roots? Okay, so we fix the first part. Yeah, we fix the first roots. Yeah, so it's become very good. So it's close to 0. But we cannot fix the second roots. You see, so catastrophic cancellation is very important. So it could be a problem. So any questions? So let me stop the recording, yeah. So then you can ask question. So stop the recording.